The plastic in your phone, the fuel in your car, and the compounds in your medicine originate in a single violent environment, the open ocean. This crude oil is trapped miles beneath the seafloor, locked under heavy layers of solid bedrock. Reaching those deposits requires multi-billion-dollar megastructures that stand as tall as modern skyscrapers. These are offshore platforms, industrial cities isolated in deep water. Engineers anchor these massive rigs to remain perfectly stationary while withstanding 30-meter-high rogue waves and Category 5 hurricanes. Securing the primary fuel of the modern world requires building permanent industrial outposts in some of the most remote and wave-battered regions on Earth. The process of breaching the seafloor begins with the derrick. This steel tower houses the rotary drill, which uses a diamond or tungsten carbide bit to shatter the rock below. This cross-section shows the drill's path through the water column and thousands of meters of solid rock to reach the reservoir. As it descends, it fights extreme friction, heat, and the Earth's upward pressure, a natural force pushing everything back up. To manage this, engineers continuously pump a heavy chemical mixture called drilling mud down the pipe. The mud cools the bit and provides the downward weight necessary to hold the well open. Success depends on a delicate physics equation, balancing the downward weight of the mud against the crushing upward force of the Earth in real time. The highest risk occurs the moment the drill bit shatters the final rock layer and enters the pressurized oil reservoir. If the underground pressure overpowers the weight of the drilling mud, it results in a catastrophic blowout, an uncontrolled eruption of oil and gas that can destroy the entire platform. To prevent this, rigs utilize a blowout preventer, or BOP. Sitting on the seafloor, this massive valve system is designed to sever the drill pipe and seal the well completely in an emergency. Once the well is secure, that same pressure becomes a tool. The Earth's internal force pushes the oil to the surface automatically, an effect similar to opening a shaken bottle of soda. This is called natural flow. Eventually, as the reservoir empties, natural pressure drops. Engineers then lower submersible pumps into the well or inject gas back down the pipe to force the remaining oil upward. This creates a strange irony. The same hostile pressure that threatens to destroy the platform is the exact force engineers harness to extract the oil. The raw fluid arriving on the deck is a turbulent slurry of crude oil, salt water, natural gas, sand, and drilling chemicals. This diagram shows the three-phase separator, designed to untangle that raw mixture. Inside, carefully managed gravity divides the fluids. Dense salt water drops to the bottom, crude oil suspends in the middle, and natural gas rises to the top. Each exits through a dedicated pipe. Extracting the oil is only half the challenge. The offshore platform must function simultaneously as a deep earth mine and a highly precise chemical refinery. From the separator, the crude oil moves to an FPSO, a massive storage vessel. Here, the oil is kept in temperature-controlled tanks to prevent it from thickening and becoming impossible to pump in the cold ocean air. Eventually, a very large crude carrier arrives for pickup. Specialized marine pilots maneuver these massive tankers into position, docking them alongside the storage vessel in open water. Once heavy steel mooring lines are secured, 5,000 horsepower pumps engage. They move 50,000 barrels of oil an hour through thick, flexible cargo hoses connecting the two ships. Urgent transfer lasts over 24 hours, during which a single spark could ignite the oil vapor and cause a massive explosion. Every liter is measured by custody transfer meters to ensure the multi-million-dollar transaction is perfectly accurate. The global economy survives on this unbroken chain of extreme engineering. Thousands of workers remain miles out at sea, turning deadly deep earth pressure into the products that power our daily lives.